Okay, we are now recording. And let me share the screen. All right, so while I'm setting the screen share, so our test is tomorrow. We don't have much of a day today, so to speak. Okay, so here's what I plan. So on the schedule, I only have to go 5.4, and I'm still allowed to do some of that tomorrow. Okay, so even though it says exam 2, you don't get the entire 2 hours for it. Okay, but you can have more than 1 hour if you wish. Okay, so I'll lecture on some of 5.4. I don't have to finish 5.4 today. Okay, we'll see how it goes. And I'll save some more for that for tomorrow. So tomorrow's a test. Okay, now I'm gonna let you ask questions at the end of today, but again, I have to leave early for a meeting. So the latest I can stick around is 12:30, but the earlier I leave, the better chance I have of getting to my appointment on time. Okay, so what I'll do today is I'll lecture up until 12 as normal, or maybe even before 12, and then we will quote unquote break, okay? And the break is actually your chance to leave if you have no questions, okay? So you know how we normally break for about 10 minutes or so, okay? If you have no questions, then you can just leave, okay? And anybody who has questions, then you can stick around, and then either Star or I will handle them. I will have to bug out around 12:30ish, or maybe if there's questions that go beyond that, Star, if you don't mind sticking around, I'll let you, handle questions if there's any after that. But there weren't any questions, yesterday or the day before, so, but that's up to you folks, okay? All right, so a reminder for tomorrow, I'll lecture a little while, maybe a little bit on 5.4, questions and answers, break, and then the test. Okay, so the minimum amount of time would be if we break out our normal time of 12 tomorrow, then we'll start the exam at 12:10. I'll send it through Canvas announcements. But hey, if you have no questions, we can just start early. Then the break will be early, like 11 something. And then we'll have our usual 10-minute break, and then you have more than an hour for the test. Okay, so now that you've already seen one test, ground rules are the same. You submit for homework, chapters 3 and 4. And I'll let you submit the homework starting right after class today. Okay, so after class, you say, I've already done the homework. You want to submit it to me, that's perfectly fine. Okay, you may not be able to fit it all in one email, so you might break it down into 2 or 3 or 4 emails, and that's perfectly fine by me. Okay, so while we're doing the test, you have to have your actual camera on with the true background, so don't have behind you, Golden Gate Bridge or something like that. I need to see actual background with your camera on. And if you have any questions during the test, send it through the chat. Don't unmute yourself. Again, think if we were meeting face-to-face, you had a question on number 5, I wouldn't want you to yell out, hey, teacher, I got a question on number 5, and disturb everybody else, right? So just ask me questions through the chat. Okay, you can have one cheat sheet, one formula sheet, 8.5 by 11, so standard sheet of paper, front and back. You can put anything you want, any formulas you want, sample problems that you want, and you can use your calculator, okay? But after that, nothing else, no other books, no notes, no internet, no people, no computers, right, for the exam. Okay, and you have the rest of the class period. So we normally end at 1 o'clock, right? So I'll end the class at 1. But again, it depends on when we start, okay? And that's up to you folks. If you have a lot of questions, we'll start and you get 50 minutes from 12:10 to 1. But if you don't have a whole bunch of questions, then we can start the test early, right? If you finish the test early, you can leave early, that's fine. But we normally end at 1 o'clock. So I will end the test again at 1 o'clock as usual. So then you have 5 minutes to go click, 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 take a picture on your cell phone, or if you have a scanner, scanners are usually nicer, it's easier to read. So if you can scan it, you can scan it. So I have to get the test by 1:05, and then the homework you have to turn in by 1:30, but you may turn in the homework early. So as soon as class is over today, I'll let you turn in the homework. That's going to be fine by me, okay? All right, so any other procedural questions about the test, send it in the chat or unmute yourself right now before I go on to today's lecture. So I don't see anything right now in the chat. All right, so we'll go ahead and get started. Okay, so 5.4, I wasn't going to do any of 5.5. I still have next week, Monday, to do that. Okay, so 5.4, here we go. It's on properties of logarithms. So properties of logarithms. starting on page 361. And you definitely want to put these on your next cheat sheet, not for tomorrow's test, but for the test after this. Okay, so there's a bunch on page 363. Okay, so summary of properties of logs. Okay, put these on your cheat sheet. So the log of a product, P times Q, is the log of the first plus the log of the second. You want to be able to go both directions on this. Okay, the log of a product, log of something times something, is the log of the first plus the log of the second. Okay, and they give you an example of that there, but I don't have to go over the example because I'll be giving you some examples right off the homework. Second one, the log of a quotient, log of something divided by something, is the log of the numerator minus the log of the denominator. Okay, so put that in your next cheat sheet. The third one is a property of exponents. Okay, log base b of p to the r power. Notice that exponent is r floating up there. It can come down in front as a coefficient. Okay, so log base b of p to the r is r log base b of p. All of these rules are both directions. So it's not just from left to right. The homework problem might have you go from right to left also. Okay, so you might start off with something that looks like that. They want you to write it like that. Or it might look like that. You go that way or the other way. The last one is a property of a function and its inverse. B raised to the log base b of p equals p. That basically says the exponential and logarithm functions are inverse functions of each other as long as it's the same base. So if this is base b, this is also base b. So if this is a 5, that should be a 5. If this is a 7, that's a 7. If that's an e, that's an e. They have to be the same. Okay, those are not the only properties, but those are some of them. Okay, and just tell you one thing, we're meeting under COVID now. If we were meeting face-to-face and COVID never existed, I'd make you guys memorize these. Okay, maybe your intermediate algebra teacher made you memorize it, but supposedly because of COVID, they told us teachers to quote unquote go easy on you. So one of the ways in which I'm going easy is I'm letting you have this cheat sheet, this formula sheet for exams. But if we were meeting face-to-face, I would have made you memorize these. Okay, so there we go. All right. There are more properties. Okay, on page 367, something called the change of base properties of logarithms. And I may not get to this today. I may get to some of this tomorrow, but okay. Main one is this one. Log base a of x is log base b of x divided by log base b of a. That's true in general, okay? But most calculators can only do log base 10 and log base e. Okay, so on a typical calculator, you have a log, which is base 10, and you have an ln, which is base e. And you can't really forget what the base is, because if you say, I forgot what the base is, all you got to do is just peek above it. So if you look above the log, it says 10 to the x. And if you look above the ln, it says e to the x. Okay, so the base for ln is e, and the base for log is 10. So even though this is true in general, in practical terms, we're normally going to switch to base 10 or base E. Okay. Truth be told, I want you to get more comfortable with ln because you're going to use ln more often when you take the calculus, because you guys are taking pre-calculus now. And after you pass pre-calculus, you'll be taking calculus. And when you get to calculus, you'll be doing a lot of ln stuff. Okay. So these are some of the properties. Okay, so I'm going to get started with some of the homework problems. So where are we? 5.4. So here we are, 1 to 25 odd, 41, 51 to 59 odd. Again, I don't have to do them all. Okay, I can still do some tomorrow. Okay, so the highest problem was problem 59. Okay, so this is on page 368. Okay, so I'll show this to you. You can watch the video for those of you who aren't getting the book. There's 1 through 10, 11 through 19-ish. 20 through, no, move it there, 26. And let's see, what was our highest problem again? 59. So we have to go up to 59. Actually, we don't have to do any of these. So let's see, we had to go to 41. So where's 41? There's 41. And then 51 to 59, 51 through 59, there we are. Okay, so we're going to try to make use of these properties of logs that are here. So I'll give you several examples of them. Okay, 5.4, page 368. Number 1, simplify. Log base 10 of 70 minus the log base 10 of 7. All right, there's a minus sign there. So that looks like that second one, right? So I take the log of the quotient, I divide them. So log base 10 of 70 divided by 7, like that. See how it works? And what is 70 divided by 7? Well, 10. And then further, anytime you see something like this, okay, so there's a little trick to this also. These technically cancel out. You have a log and here, but what do I write? The key is that you pretend there's a 1 there. Okay, so in red, there's a 1. Log base 10 of 10 cancels out. So the final answer is just 1. Whoops, that pen seemed to run out of ink. So final answer is 1. Okay, so this part, make it into a quotient, 70 divided by 7. Log base 10 of 10 is like log base 10 of 10 to the 1. These cancel out, so the answer is automatically 1. Okay. This problem's finished, but I'll just dig deeper. If you see log base 10 of 10 to the 8th, then the answer is automatically 8. You would cancel all this stuff out. Okay, it's a log and an exponent back to back, so function with its inverse. Okay. Okay, number 5, log base 3 of 108. Plus log base 3 of 3/4. Log base 3 of 108 plus log base 3 of 3/4. Okay, there's a plus sign there. So that looks like the top one, right? Log of the first plus a log of the second is a log of the product. That means I multiply the two. So log base 3 of 108 times 3/4. Okay, and you can punch that in your calculator and it comes out to be 81. Okay, how do I finish that? Call it X. And then I'm going to unscramble it. I've been calling it unscrambling it. 3 raised to the X equals 81. So remember we did this the other day, right? So base is 3, exponent is X, come back in for the result. Okay, so what exponent do I want up here? So I end up with 81. 3 to what power is 81? The answer is 4. 3 to the 4th power, 3 times 3 times 3 times 3 is equal to 81. So my answer is going to be 4. Okay. All right. 7 is kind of clever. -1/2 plus ln radical e. Okay, now square root of e is e to the 1/2 power. Now, anytime you have ln and e back to back, they cancel out. Remember, they're inverse functions of each other. Okay, so again, ln and e to the x are inverse functions. Log and 10 to the x are inverse functions. Okay, that means you can just cross these out. And you have -1/2 plus 1/2, which is simply 0. So the answer is just going to be 0. Okay, let me raise it up again for focusing. I'll go back to the top so you can catch the video later if it was out of focus at first. Okay. All right, number 9, 2 to the log base 2 of 5. Minus 3 log base 5 cube root of 5. Okay, these cancel out. It's an exponential and a logarithm function to the same base, base 2, base 2. So that's just going to be 5. This one, first I need to write that as 5 raised to the 1/3. And now this combination gets to cancel out. Okay, again, it's a logarithm and an exponential function to the same base. Okay, exponential, log function, same base. Okay, so they cancel out. So 5 minus 3 times 1/3, and now it's very easy. 3 times 1/3 is 1. So 5 minus 1, final answer is 4. Okay. All right, something like 13, please. Log base 5 of 6. Plus log base 5 of 1/3. Plus log base 5 of 10. Okay, these are pluses. That means I multiply them. It's just like this one. So log base 5 of 6 times 1/3 times 10. And that comes out to be 2 times 10, 20. Log base 5 of 20. Okay, and for this particular one, that's all you can do. So we'll just leave it alone. (15a). ln, which stands for natural log, 3 minus 2 ln 4 plus ln 32. All right, this has a coefficient. So the first thing I'm going to do is put the coefficient up as an exponent. The third one there. Okay, see that r log base b of p on the right-hand side? It's going to climb up and become an exponent over here. Okay, so that will climb up to there. Like so. So ln 3 minus ln 4 squared plus ln 32. Okay, then I go like this, ln 3. This one's a minus. That means it goes in a denominator over 4 squared, but 4 squared is 16. And since this is a plus, it's going to be times 32. Okay, so ln 3, the minus sign means 16, 4 squared goes in the denominator. The plus means you multiply 32. And that's going to be 32 divided by 16 is 2. ln 6 is my final answer. Natural log of 6. Okay. All right, 19 is a fairly long one. So you can get all that down. 4 log base 10 of 3 minus 6 log base 10 of x squared plus 1. Then they got this super long thing. 1/2 log base 10 x plus 1 plus 2 log base 10 of 3. Oh boy.
That's minus 2 log base 10 of 3.
Minus 2 log base 10 of 3. Thank you. So minus. Unfortunately, once you make it a plus, this you can white it out. It should be like so. Okay, let me double check that I wrote it correctly, which is probably the hardest thing for me to do right now. Okay. Let's distribute here. So leave this alone. Plus 1/2 log base 10 of x plus 1. Then 1/2 times a negative 2 is just a negative 1. Okay. In actuality, I don't even have to put the tens. If you have a log and you don't see a 10, it's understood to be base 10. Okay, so if I just write log, it means base 10. It's understood. Okay, but we've got it. All right, so all the exponents are going to climb up. 4 goes up there. 6 goes up there. 1/2 goes up there. Okay. So log base 10 of 3 to the 4th minus log base 10 of x squared plus 1 to the 6th power plus log base 10 of x plus 1 to the 1/2 minus log base 10 of 3. Okay, now we're going to write it just as a single logarithm. All the pluses, which includes this one. This one's a positive. So that one and that one stay upstairs. That one and that one go in a denominator because they're negatives. So 3 to the 4th stays on top. And what is 3 to the 4th? It's 81. Times, if you raise something to the 1/2 power, it means square root. So square root x plus 1. So that one goes here. So these are both in the numerator because they're both positive. I mean, you can pretend there's a plus here, right? These two go downstairs because they have negatives. Okay, so x squared plus 1 to the 6th power times 3. But if it's times 3, you can put it in front, I guess. So go like so. Okay, so top 81, top radical x plus 1, bottom x squared plus 1 to the 6th, and a 3. And last thing, 81 divided by 3 is 27. So best final answer, log base 10 of 27 radical x plus 1 over x squared plus 1 to the 6th power. So that's the best final answer for that one. Okay. 23A. Go like that. Okay, square root. Well, square root means raise something to the 1/2 power. And now that 1/2 power gets to come down in front. It's the opposite of what we did over here, essentially. So 1/2 log base 10 of 9 minus x squared. Okay, so that's all you have to do for that one. B is much longer. ln radical 4 minus x squared over x minus 1 x plus 1 to the 3/2. Okay, so since this was a division, it's going to be ln of this minus ln of this minus ln of this. Okay, so that's using this other property in reverse. Okay, I'm using the second property in reverse, the one with a minus sign. Okay, the one that says log base b of p over q, log base b of p minus log base p of q. So since both of these are the denominator, they're going to be written as minuses. So ln square root means raised to the 1/2 power. And these are both going to be minuses. So minus ln x minus 1 minus ln x plus 1 to 3/2 powers, like that. And then this comes in front, this comes in front, and that's it. So you see we're just reversing the process. Okay, so that's what I mean by get ready for these problems to go both directions. You might go from left to right, you might go from right to left, depending on what they start off with. Okay, so final answer is 1/2 natural log of 4 minus x squared. Again, ln stands for natural log, minus natural log x minus 1 minus 3/2 ln x plus 1, like that. Okay. All right, then let's see. 25, you have A and B. B looks a lot harder. So let me do B, although maybe it isn't so bad after all, once I think about it. Okay. 25B. Two natural log of a great big square root. They have 1 plus x squared, 1 plus x to the 4th, 1 plus x to the 6th. Okay, if I have the square root of all that, it means raise all that junk to the 1/2 power. Now, I have a property of logs that says this thing can come down in front and multiply by all this. But what's 2 times a half? It's going to be 1, right? That's nice. Gone. How do you like that? By the way, you could alternatively say, I can make the 2 climb up. You could bring the 2 up there. Then as an exponent, you'd have 1/2 times 2, which is also 1. And then if you raise something to the first power, you normally don't write it. Okay, ln of a product, just write it as a sum of logs. So it's ln of 1 plus x squared plus ln 1 plus x to the 4th plus natural log 1 plus x to the 6th. Okay, and leave it like that. And in case you're wondering, can I do anything more with this? No, you can't distribute. Like, can I go ln of that plus ln of that? No. So if ln of a sum like this, you just leave it alone. So that's as good as it gets. Okay, so I've shown you 1 to 25. Get you on 41, and I won't go much farther beyond that. Okay, 41, graph and determine x-intercepts. Okay, so let's see. A, y equals 2 to the x minus 5. So that's a review of drawing the exponential function. Okay, 2 to the x generally looks something like that. 0, 1. Minus 5, go down 5 units. So if I go down 5, that would become 0, negative 4. Something like so. Okay. And then it says determine x-intercepts. That means y equals 0. I'll have to show you how that works. Said y equal to 0. 0 equals 2 to the x minus 5. Okay, add 5 to both sides, like this. Okay, the technique to solving something like this is to take the log of both sides. You could pick any log that you want. Okay, I want you to start getting used to the ln function. So ln both sides. So ln. The reason why you want to do that is now the x gets to come down in front. So you have ln 5 equals x ln 2 divided by ln 2. So x is ln 5 divided by ln 2, like so. Okay, then it's just a calculator thing. So natural log 5, ln 5 divided by ln 2, ln parentheses 2. In some of your calculator, it pops up with the left paren, so you have to close it with the right paren. 2.3219, something like that. 2.3219. Okay. (41b) is almost the same thing, but they just have a slightly more complicated exponent. Y equals 2 to the x over 2 minus 5. Well, let's see. If I just look at this, when I plug in 0, I still get 1. So it has the same basic shape as this one. When I plug in 0, I still get 1. And once again, I go down 5 units. 0, -4. It looks like that. Very, very similar. Right? And then this time it asks for the X-intercepts again, which means y equals 0. Remember, X-intercept means y equals 0. In other words, where is this point? So we sort of do the same thing, but just a little bit harder. So 2 to the x over 2 minus 5 equals 0. Okay, so almost the same as this, only a little bit more work. So add 5, 2 to the x over 2 equals 5. Okay, again, to get the exponent down, I take the natural log of both sides. You ln both sides. Very technically, you could pick any other base, like log base 10, but I want you to get used to ln. Okay, once you have the ln there, this thing gets to come down in front. So x over 2 ln 2 equals ln 5. Divide both sides by 2, by ln 2. That cancels out. X over 2 equals ln 5 over ln 2. And if you look at what we did here, all the algebra is exactly the same as here, except instead of just x equals blah, 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 I have x over 2. So how do I get rid of divided by 2? Multiply by 2. So in this case, the answer is 2 natural log of 5 over natural log of 2. In other words, it's just twice as big as this. Or I just take the answer I got here and multiply by 2. So I still have it in my calculator. Okay, so that thing just times 2. 4.6439. Okay, so I just took this answer and multiplied it by 2. I got something like that. Okay. I'm just about done, folks. I was just going to introduce the last problems, which I can save for tomorrow. So I've done 1 to 25, 41. Okay, 51 to 59, I might do 1 or 2 at the most. I can save the rest for tomorrow. It'll take me maybe 15 minutes. Okay, so again, tomorrow when you come into class, I'll knock off the rest of these 10 or 15 minutes, question and answer, and then we break and we take the test. So if you don't have a whole bunch of questions, that means you're going to have maybe an hour and a half to do the exam, okay? So for 51 through 59, okay, you have to do the change of base formula. Which is right here on page 367. Log base A of x equals log base B of x over log base B of A. So if you have a log to some other base, by the way, some of you have a calculator that can do that. I don't want you to rely solely on that. You have to show me the change to the base 10 or the base E log. Okay, and I'll show you how I want you to do that. Okay, but the rules in general are log base B of A. You can make it base 10 as a log of A divided by the log of B. I mean, you can kind of tell which is on top and which is on the bottom, right? That looks like it's higher up than that one. Okay, and you can also do ln A over ln B, like so. Okay, some of the problems, they want you to do base 10. This is base 10. Some of them will say base E, then you do this. And the answer should be the same either way. Now, 51 through 55, it says express in terms of base 10 logarithms. Okay, then 57, 59, they want you to do it in terms of base E, natural logarithms. Okay, so I'll show you how to do that. All right, so 51. Log base 2 of 5. So do it in terms of base 10. So that's log of 5, the top one, divided by log 2. And again, I don't have to write the 10 here. If you don't put any number, it's understood to be base 10. Okay, and in case you're wondering, you cannot cancel these out. You might say, oh, can I just cancel that out and get 5 over 2? The answer is no, it doesn't turn out to be the same thing. Okay, so just punch out log of 5 divided by log of 2. So on this backwards calculator, 5 log divided by 2 log equals 2.3219. Notice anything about that number? We just did it over here with a natural log. Bottom line, it doesn't matter what base you use. Okay, if it did log 5 over log 2 or ln 5 over ln 2, you get the same result. That's always going to happen. Okay, which is very curious. Okay, and by the way, if you just do ln 5, it's not the same as log 5. If you just do ln 2 and log 2, they're not the same. But somehow when you take the quotient, when you divide them, you get the same thing. Okay. Yeah, I can illustrate that pretty easily. ln 5. Okay, there's ln 5 and log 5. ln 5, log 5, very different. Okay, and also ln 2 and log 2, very different. But when you divide them, you get the same ratio. Okay, so that's not the same as that. That's not the same as that. But when you take that divided by that, you get the same thing as that divided by that, which is very interesting indeed. Okay. All right, so that's that kind of problem. And then show you one in terms of ln, and then I'll be done. 59. Log base 10 of e, right, in terms of natural logs. So I do ln of this divided by ln of this. Ln of e divided by ln of 10. Okay, and interesting here, ln of e is 1. Okay, you can sneak in an exponent of 1 here, if you wish. These cancel out. So 1 divided by ln 10. 1 divided by ln 10. 1 divided by ln 10. 0.43429, I'll call it 4343. And there we go. Okay, I'm done, folks. I'm not quite done with the section. I can save a little bit of that for tomorrow. Okay, all right, so it's almost noon. Okay, so we are going to quote unquote break until 12:10. And then starting at 12:10, I'll let you ask questions if anybody has any from chapters 3 and 4. If you have no questions and answers, you may leave. Bye, and I'll see you tomorrow. So you have 10 minutes to sneak out. I won't mark you, absent for that. And then up until, so 12:10 until a limit of 12:30ish, I have to run off to a meeting, but we'll see how it goes from there. Okay. So let me check what was in the chat. Okay, that's all that I have there. Okay, so I'm actually not going to record anymore. I'll stop the recording because there's no more formal lecture, right? So I'll turn off the recording.